discussing sampling distribution. What is sampling distribution? A sampling distribution is defined as a probability distribution of the values of a statistic, such as mean, standard deviation, proportion, etc., computed from all possible samples of same size, which might be selected with or without replacement from the population. So, what is sampling distribution? Sampling distribution is simply the probability distribution which we have discussed before, but this is the probability distribution of the values of statistic. Now, what is statistic? Previously, we have discussed what is statistic. Statistic is a numerical quantity computed from the values of sample. So anything you measure from or compute from the values of a sample, it is called statistic. For example, the mean of the sample, the standard deviation of sample, or the proportions of sample. So anything, any quantity which you measure in from the sample, from the values of sample, are generally called statistic. Now, it has been mentioned here that the selection will be with or without replacement. So let us see what is sampling with and without replacement. First of all, we are going to discuss sampling with replacement. Sampling is said to be with replacement when from a finite population a sampling unit is drawn, observed, and then returned to the population before another unit is drawn. So what is sampling with replacement? That if you have selected a unit, a sampling unit, or if you have selected a sample from the population and then you have observed it, and before drawing another sampling unit you have put it back, then or you have returned it to the population, so it is called the sampling with replacement. Now the population in this case will remain same because no sampling unit is deducted or no sampling unit is placed apart, but the sampling unit which we have observed is returned back to the population. And the sampling unit might be selected more than once. Yes, obviously, because if you have selected, suppose you have a bucket and you have written numbers from 1 to 100, and if you have selected uh, slip of paper and there 22 is written, and then after observing you have put this 22 back in the bucket, so there are chances that this 22 will appear in next draw. Okay, now sampling without replacement: if a sampling unit is chosen and not returned to the population after it has been observed, the sampling is said to be without replacement. Now, a sampling unit is selected and it is not returned to the population, so it is called sampling without replacement. Now here the sampling unit cannot be selected again because it is not replaced in the population, so it cannot be selected again for that sample as the sample unit is not replaced. So I think you can now make the difference between the sampling with and sampling without replacement. Now, starting sampling, there are many types of sampling distributions, but the first type is sampling distribution of mean. Now, what is sampling distribution of mean? The sampling distribution of the mean is the probability distribution of means x bar. Now, mean of the sample is denoted by x bar. Of all possible samples of the same size that can be selected from a given population, the mean of this distribution is represented by mu x bar. This symbol is called mu, and and we write this as mu x bar, and the standard deviation, which is called the standard error of the mean, is represented by sigma. This sign is sigma x bar or SE x bar. So this is what is the sampling distribution of mean. You will you will find the samples, or you will draw the samples of all possible samples from the population, and then for each sample we will calculate the mean of each sample, and then mm, what is the sampling distribution. When you get all the possible means, you draw the probability distribution, or you calculate the probability distribution of these means, then this is called the sampling distribution. However, when we will solve the questions, it will be more clear to you. Now, properties of the sampling distribution of mean. The mean of the sampling distribution of mean is equal to the population mean. So in our questions we will prove this property, so it will be more clear to you. Then standard error is equal to sigma by under root n if it is sampling with replacement, and sigma by under root n multiply by whole under root n minus small n and n minus 1 without replacement. Both with or without replacement will be mentioned in your question. So if the sampling is with replacement, you are going to use this formula for standard error, and if the sampling distribution is without replacement, so you are going to use the other formula. So starting the question, it will be more clear to you. This is the question from question number 14.27 from your book, and what this question says, that the given the population 2 4 8 8 10 10. So this is the population, this is given in your question. How many samples of size n is equal to 2? Now small n shows the size of the sample. What is the size of the sample? It is the number of elements in a sample, in one sample, in each sample. So there n is 2, so this means that in each sample the number of elements will be just 2, can be drawn without replacement. Now as I have told you before that the with or without replacement will be mentioned in the question. So it is mentioned here that the sampling is done without replacement from the population. Now compute and tabulate the sampling distribution of the mean for sample of size n is equal to 2. Now first of all, the first step is that you will write the population, the elements of the population. You will mention that this is your population. Then capital N is the size of population, means the number of elements in the population. So if you count, there are 6 elements in this population, so n is 6, and small n sample size was given in the question, so it is 2. Now the possible number of samples. Now the next step is to find the possible number of samples. So if the sampling is done without replacement, we will use this formula NCN, n combination small n. So you are familiar with combination, you can find from the calculator. So 6C2 is 15. So this means that there will be possible 15 possible samples. So now what is the way to find construct or to write these samples? Okay, now you have to make 2 columns, one for sample and other for x bar, which is mean. Now if the sampling, because this sampling in this question it was mentioned that sampling is without replacement, so what is the process? Now this is your population, so you will start from here 2 4, you can see here 2 4, then 2 8, then 2 8, then 2 10, and 2 10. Now there is no repetition. This 8 is on the third position, this 8 is on the fourth position. They are separate elements, they are not repeated, so they are separate elements. Then 210, then 210. So up till here 2 is finished, then we will leave 2 and then we will start with 4. 4 8, 4 8, 4 10, 4 10. So you can see here up till here. Then we will leave 4, then 8 8, here you can see 8 8, then 8 10, then again 8 10. Okay, now we will leave this 8 and with this 8 10, this is 8 10 and 8 10, and at the end 10 10. So if you count them, they are 15 samples. Now for each sample, as I have told you that for each sample we have to compute the mean x bar. So how we compute the mean? We add the values and divide by the number of values. So in this sample we have just two values, so we will add these two values and divide with 2 because there are only two values. So 2 plus 4 6, divided by 2 3, then 2 plus 8 10, divided by 2 5, again 2 plus 8 10, divided by 2 5, and in with similar way I have find all the means. So here we have got all the possible means from the possible samples. Now what next we are going to use, this is the sampling distribution which we are going to, this is our main work which we are going to do. So now we will write all possible values of the mean, not repeated value, just once we will write like this 3 5 6 7 8 9 10. Just we will write each value once, and then I have written these all the values of x bar once, and then I will write frequency. Then we will write frequency. Frequency, what is frequency? The number of occurrence. So here we can see that 3 occurs only one time, so I have written in frequency 1. Then 5 occurs 2 times, so I have written in the frequency 2, and up to so on. And when you add, this is the check here, when you add all the frequency column, so the number should be 15 because here the possible number of sample was 15. So the number should match the all possible number of samples. So it is now 15 here. Now next step is probability, because we have discussed in the definition that what is the sampling distribution? It is the probability distribution. So we have to find the probability of each of the x bar. So what is the probability? Chance of occurrence divided by total. So the chance of occurrence of 3 is 1 and divided by 15. Okay, then 2 divided by 15, then 4 divided by 15, and up to so on. And if you add them, it will always become, this probability column should always become 1. Okay, then x into p of x bar, x bar into p of x bar. You have to multiply this column with first column. So when you multiply this, this will become 1 by 15, then 2 multiply by 5, 10 by 15, and up to so on. And at the end the result is 7. Okay, then last column is x bar whole square multiply by p of x bar. So here what you will do, you will take a square of this column or this number, square of x bar, and then you will multiply by this. So when you take square of 3, it will become 9, and when you multiply by 1 by 15, so it is 9 by 15. Then 5 is 25, 25 multiply by 2 is 50 and up to so on, and the final result here is 52.6. Now, verifying the properties. So, first property was the sampling distribution of mean. The mean of the sampling distribution of mean is equal to the population mean. Population mean is denoted by mu, and the mean of the sampling distribution of mean is denoted by mu x bar. So, mu, the formula for mu, you are familiar with this. The formula for mean is sum of all the values divided by number of all the values. So, sum of all the values mean adding all the values, and the number of values were 6. So, when you add all the values divided by 6, you get 7. And what is the sampling distribution? Mean of the sampling distribution of mean is equal to summation x bar into p of x bar. So this column we have constructed here summation, x bar into p of x bar. Summation means sum. So sum of this column is 7. So here first property is verified. Now second property, because this was sampling without replacement, so sigma x bar is equal to sigma by under root n multiply by this finite correction factor, which is equal to capital N minus small n, capital N minus 1. So first of all we'll go with this left hand side. This is equal to whole under root into summation, this is x bar square. So x bar square into p of x bar minus whole square summation x bar into p of x bar. So this we have constructed again this column. So it is 52.6, and this result we have got already from here. So this is 7 square. When you take 7 square, it is 49, and when you solve, the final answer is 1.89. Now the right hand side. For the right hand side, first of all we'll construct sigma. What is sigma? Sigma is the standard deviation, and hopefully you have solved the questions about standard deviation. So it is equal to whole under root summation x minus mu whole square divided by n. X is the each of the value of the population, and mu is the mean. So first value of the population was 2, so 2 minus, and mu is 7, so 2 minus mu whole square plus 4 minus 7 whole square plus 8 minus 7 whole square, and up to so on, divided by 6. And when you gradually solve this question, the answer is 3. Now putting in the right hand side, so small n is 2, capital N is 6, and when you solve first this, you divide this, so it will become the answer is 2.12, and when you solve this portion, the answer is 0.893. So look, this is exactly the same answer, 1.89, which was here. So it is also, the second property is also verified. Now this is an example. Quickly we will get the review of this example. Given a population 1, 3, 4, 5, 7, construct the sampling distribution of mean for all possible samples of size 2 drawn with replacement. Now difference is here that this is with replacement. Also verify the properties of the sampling distribution, which we have done before. So first of all, I have told you before, that we'll write population. So this is population. Now here are 5 elements in the population. So capital N is 5, small n is again 2, and now possible number of samples with replacement. Possible number of samples with replacement is given as capital N power small n. So capital N is 5, power small n is 2. So and this becomes 25. Now we have made 25 samples and constructed their means. So first sample is Now this is with replacement, so 1 can occur 2 times. So we have started with 1, then 1, and 1 3, 1 4, 1 5, 1 7 up till here. Then we switch to 3, so 3 1. This is the main difference, because in sampling without replacement we left this first one and we started with the next, but if sampling with replacement we again select the first one. So 3 1, 3 3, 3 4, 3 5, 3 7, and up to so on. And then for each sample we have calculated here the mean. 1 plus 1 is 2, divided by 2 is 1. Then 1 plus 3 is 4, divided by 2 is 2, and up to so on for all 25 samples. Now again the same process, I have written the values of mean once, and then we have written the frequency, and when you add the frequency should become 25, because the total number of samples here are 25. Then again probabilities and the other columns are same. Again verifying the property, first property is mu x bar is equal to mu. So the value of mu x bar is summation x bar into p of x bar. Summation x bar into p of x bar, we have this column x bar into p of x bar, which is equal to 4. So this is 4, and then what mu is equal to sum of all the values of population divided by number of values. The sum of all the values is equal to 20, divided by 5 4. So this property is verified. Again now we are not now we are using another formula, because this is sampling with the replacement. So this formula is quite easy, sigma by under root n. Now as we have discussed in previous question, the same process we are going to do in this. Now here we have got the answer in points 1.414, which is approximately equal to 1 when you round off it. And then sigma, the process for sigma is same as we have done before, and you got here under root 2. Under root 2 divided by under root 2 is equal to 1. So this property is also verified. Thank you. This is all for today.